When we look at global trade, the sheer physical scale is overwhelming. Millions of tons of materials are constantly in motion across oceans and continents to fulfill global demand. It is tempting to reduce this complexity to a simple logistical exercise, the mechanical process of moving physical boxes from a factory to a warehouse and eventually to a consumer. But that definition is incomplete. The true purpose of a supply chain is to deliver precise customer value. That means ensuring product availability, maintaining speed of delivery, and guaranteeing absolute reliability. Delivering that value requires a continuous, calculated balancing act between four conflicting metrics: cost, service level, systemic risk, and cash flow. Treating this system purely as an exercise in cost-cutting limits a company's potential. An optimized supply chain acts as an engine for business growth, driving top-line revenue by enabling new market opportunities. We must treat supply chains as strategic weapons for competitive advantage, as they have evolved past their traditional role as operational overhead. To achieve this, we need a precise academic definition. A supply chain is the end-to-end network of organizations, people, processes, information, and resources involved in sourcing, making, delivering, and returning products. This definition requires looking beyond individual company borders. A supply chain is not a single corporate entity or an internal department. It is a dynamic system of interconnected flows that span multiple, completely independent organizations. Analyzing these overlapping network flows across different companies, rather than isolating individual departments, forms the foundation of modern operations management. To map this architecture, we start with a foundational, sequential model to trace the physical path products take. This diagram illustrates the baseline linear sequence, divided into two specific macrophases: the creation and maintenance of goods on the left, moving toward customer interaction on the right. Looking at the creation phase, we see the upstream sequence. It begins with procurement of raw materials, moves into manufacturing, and advances through distribution and storage networks. As physical goods cross downstream, the focus shifts to customer interaction, shipping, the sales transaction, and post-sale customer service. In the fast-moving consumer goods sector, this path is highly visible. Raw agricultural materials are sourced, processed in manufacturing plants, routed to regional distribution centers, and finally placed on retail shelves. The exact same linear structure applies to vastly different industries, like healthcare. Here, pharmaceutical producers supply wholesalers, who then distribute life-saving medications to hospitals and local pharmacies. While this linear path is a necessary baseline for understanding the physical movement, it only represents the surface layer of a much more complex, multidimensional operating environment. The physical movement of goods is entirely dependent on two invisible flows operating simultaneously. This chart shows how those operational stages actually intersect. The blue circles representing physical movement, like production and transporting, are intersected by a central green column containing trading, finance, and investment. The first flow is physical, tangible materials moving steadily from upstream raw materials on the left to downstream retailers on the right. The second is the information flow. Critical demand signals and orders must move bidirectionally across this entire map to trigger physical production. The third is the financial flow. Those central green nodes represent the working capital, payments, and credit terms that act as the lubricant for the entire system. To govern these three intersecting flows, the industry relies on 5 standardized operational processes: plan, source, make, deliver, and return. A supply chain only functions successfully when the physical capacity to make goods, the data signals to know what to make, and the working capital to fund the process are perfectly synchronized across all nodes. Because these flows cross multiple independent company boundaries, the resulting system is dynamic and highly susceptible to volatility. Managing that constant uncertainty requires making continuous, calculated trade-offs between cost efficiency and service reliability. To prevent cascading failures across the network, operations managers rely on a strict governing principle known as systems thinking. Systems thinking directly opposes the common managerial flaw of local optimization. If a single factory runs at maximum speed to improve its own production metrics, it often creates a massive bottlenecked pileup of red inventory blocks at the next warehouse node. By optimizing its own localized output, that factory actively damages the overall health of the network by tying up critical cash in excess immovable inventory. The operational rule is clear. Overall flow efficiency across the entire chain must always supersede localized functional efficiency within a single department. Failing to apply this principle leads to the bullwhip effect, a phenomenon where very small changes in customer demand at the retail level cause massive, amplified disruptions in upstream production. A supply chain manager's true responsibility is optimizing the health of the entire multi-company chain, rather than maximizing the specific metrics of their individual operational silo. These theoretical principles dictate daily executive decision-making across global enterprises. Analyzing the three flows directly informs the physical design of distribution networks and determines which specific processes should be outsourced to partner organizations. The need to balance cost against risk dictates strict inventory policies, requiring managers to mathematically determine exactly where to place decoupling points to buffer against market volatility. These concepts are also applied in sales and operations planning, or S&OP, ensuring that high-level corporate strategy perfectly aligns with actual physical execution on the factory floor. Ultimately, every major supply chain decision is an exercise in balancing physical, informational, and financial flows against harsh market realities. Today, those market realities are defined by extreme macroeconomic volatility and frequent severe global disruptions. This creates an intense tension for executives, forcing them to decide whether to design their networks for maximum cost efficiency or to build in redundancy for resilience and risk mitigation. Simultaneously, there is growing regulatory and consumer pressure to transition away from traditional linear consumption models towards sustainable, circular supply chains that recapture materials. The primary tool to combat these overlapping challenges is digital visibility. Companies are deploying artificial intelligence and centralized control towers to analyze demand signals in real time, predict potential disruptions, and automatically reroute physical flows before bottlenecks occur. Future competitive advantage belongs to the supply chains that prioritize this digital visibility and rapid adaptability over static, rigid cost-cutting. To summarize, a supply chain is a complex end-to-end system of physical, informational, and financial flows, encompassing far more than the traditional scope of internal logistics. Second, operational success strictly requires systems thinking. Global flow efficiency must always take priority over local optimization. Third, managing this network is a perpetual, dynamic exercise in balancing cost, service, risk, and cash. Mastering this architecture is the foundational requirement for leading any modern enterprise.